In this lesson, we will write a program to find the factorial of a positive integer n, and we will do so using a very important and powerful programming concept called recursion. The prerequisite for this lesson is that you should know about functions in programming. Now, as we know in mathematics, factorial of n is defined as the product of all the integers from 1 to n. So n factorial is written as n into n minus 1 into n minus 2, and we go on multiplying with all the integers till 1. Now we also know that n minus 1 into n minus 2 all the way till 1 here is nothing but n minus 1 factorial. So we also say that n factorial is actually n into n minus 1 factorial. And this is true for all n greater than 0. 0 factorial is a special case and it is equal to 1. So we'll write it something like this. N factorial is n into n minus 1 factorial if n is greater than 0, and it is equal to 1 if n is equal to 0. And this is nothing but the case for 0 factorial. So we have a function for n factorial here. When we write a function in a simpler form of itself, we call such a function a recursive function. So for example, here we have written n factorial in the form of n minus 1 factorial. So this function is a recursive function. Now the concept of a recursive function is also valid in the context of a programming language. So I will write a recursive function to calculate factorial here. So let's say we write a function that returns an integer, and the name of the function is factorial. It takes an integer as input, so we'll say int n is the input, and the function goes like, if n is equal to 0, simply return 1, else return n into factorial n minus 1. So now we can see that within the function or the method factorial, we are calling the method itself, though with a changed argument or a reduced argument. So when we call a method within itself, we say that such a call is actually a recursive call. Let us now see how computer understands and executes this particular method. Let's say we want to calculate factorial 4, and we have asked for factorial 4, and I will write f4 here as shortcut for factorial 4, and I will draw two columns here, and I'll come back to why I'm drawing these two columns. Now when the computer tries to calculate f4 here, it sees that it actually is calling f3 recursively. So what it says that, hey, I will pause the execution of this particular function f4 and go and calculate f3 first, and then I'll come back. So it saves the current state of f4 into memory and goes on to calculate f3. Now f3 again makes a call to f2. So machine or computer again pauses this execution of f3 and goes to calculate f2. Now f2 again calls f1, so we pause this again and we keep going. F1 again calls f0. Now when we come to f0, then there is no recursive call any further, and if you can see in the left, then this condition holds true. So n is 0 here, and we simply return 1 here. So this f0 was kind of a base condition, and if it was not there, then this particular recursion would have gone endlessly. Now f0 simply returns 1 here, and it finishes, and computer again resumes f1, and because we have got f0 now, and now it calculates f1, and now f1 finishes, and f2 is resumed. This r here is for resume. Now f2 is calculated and it returns back the value 2. Now as f2 finishes, f3 resumes and it finishes, and finally we get back to f4. Now f4 finishes and returns probably to the main method. Now let us quickly try to see this in an actual compiler, in an actual C++ code. Now I have written a method factorial that takes as input n and returns an integer. I'm using Visual Studio Compiler, and if you use some other compiler or some other syntax of writing C++, do not bother, you will still get the logic right. So what I'll do here is that I'll take an input n from the user. So I'll ask the user that, hey, give me an n, and I'll input this n, and then I'll have another variable result that will make a call to that will store the output after factorial of n returns, and we'll simply print this result. Now let us run this and see what happens. So let's give n is equal to 5, and this gives us as output 120, which is factorial 5. Now I will try to do something else here. I'll first remove this else condition because it is redundant. We do not need to put this because once we return something, the program does not execute any further in that function. Now what I'll do is that I'll have a variable, say f, that will store this particular value, and we will return this f here. Now I'll try to write two statements. One in the beginning, I'll say that I am calculating f of n, and one after this recursion is complete and I have the value in f, I'll say that I am done and f of n is actually equal to f, and I'll put an end line here. So basically what I'm trying to do here is that when I'm entering this function, I'm printing something like I'm calculating fn. So if n is 5, we say I'm calculating f5 and then f4 and so on. And when I have this particular value f, then I'm saying that okay, now I have f5 is equal to this. Let's quickly run this program and see what happens. So let me give an input, and this time again we'll give 5. Now let us see what we are printing here, or rather the program is printing here. It says first that I'm calculating f5, but it does not say immediately in the same function that I'm done with f5. It kind of pauses here and goes to calculate f4, similar to what we had shown you earlier. And then again, it does not say I'm done with f4. It goes on to calculate f3 and then f2 and then f1, finally to f0. And for f0, we have not printed anything here that I'm done or something. So first f0 finishes, then f1 finishes, and we come back finally like f2, f3, f4 and f5, and finally f5 is 120. Now a very common error while doing recursion is that when you do not take care of the base condition well, or rather the termination condition for the recursion well. So if you do not write this termination condition well, your recursion could go on endlessly, causing your memory to overflow and your program to crash. So a lot of things happen behind the scene when you write recursion. A recursion is often very simple to write and easy to read, but it's really important that we understand all the things that happen behind the scene. In the next lesson, we will show you another implementation of recursion, which is Fibonacci sequence, and we'll show you what other things to take care of while writing recursion and why recursion may not be the best thing to write always. So thanks for watching.